Linux is a multi-user operating system. Every file has an owner. Every process runs as a user. And the permissions on every file control exactly who can read it, write to it, or execute it. Understand permissions and you understand who controls what. Misunderstand them and you leave doors open. This episode is about file permissions and users. We will compare files with difference, escape a restricted shell environment, and exploit a setuid binary to run commands as another user. Let's get right in. Connecting to level 17. Logged in as Bandit 17. There are two files, passwords.old and passwords.new. The password for the next level is the only line that changed between them. We need difference. Difference compares two files line by line and shows only what changed. Lines marked with a less than symbol are from the first file. Lines marked with greater than are from the second. The line marked with greater than is the new line, the one added to passwords.new. That is the password for level 18. Difference is a core tool for incident response, code review, and config auditing. Anytime you need to know what changed between two versions of a file, difference tells you instantly. Level 17 done. Connecting to level 18. Watch what happens when we connect to level 18. Bye. We were immediately logged out. Someone modified the .bashrc file, the script that runs every time bash starts. It executes an exit command before we get a shell prompt. We need to bypass it. The trick is to tell SSH to run a command directly without starting an interactive shell at all. The T flag allocates a terminal, and we pass the command we want to run as an argument to SSH. Enter the Bandit 18 password when prompted. There is the password for level 19, and we were immediately kicked out again. But this time we got what we needed first. SSH executed cat readme before bash could run .bashrc and terminate us. Client-side controls can be bypassed. Always. Level 18 done. Connecting to level 19. Logged in as Bandit 19. This one introduces one of the most important concepts in Linux privilege escalation. Let us look at what is in the home directory. There is a binary called bandit20s do. Notice the permissions, that lowercase s where the execute bit should be for the owner. That is the setuid bit. It means this binary runs with the permissions of its owner, not the person executing it. The owner is Bandit20. Let us run it with no arguments to see what it does. It runs a command as another user. So whatever command we give it runs as Bandit20, even though we are Bandit19. We can read Bandit20's password file directly. There is the password. This is privilege escalation at its most fundamental. We, Bandit19, just read a file owned by Bandit20 by running a setuid binary that temporarily elevated our effective user ID. This exact mechanism is at the heart of countless real privilege escalation exploits. The bashrc command on your own Linux system uses the same setuid mechanism. It is owned by root with the setuid bit set, which is why a normal user can change their own password even though the shadow file is root only. See it, the S in the permissions, owned by root. Same principle. Designed intentionally. But when a developer puts the setuid bit on a binary that was never meant to have it, or one that can be abused, that becomes a privilege escalation vulnerability. Level 19 done. And that is episode 5. Difference to spot changes, SSH command injection to bypass a hostile shell environment, and setuid binaries to run commands as another user. 3 different permission concepts, 3 different exploitation techniques. Episode 6 is where things get automated, cron jobs, background diamonds, and scripts that run without anyone pressing enter. We will read them, reverse engineer them, write our own exploit scripts, and brute force a pin with a bash loop. Subscribe and follow the series. Drop a comment if you found another way to bypass the level 18 shell restriction. There is more than one. See you in the next one.